Call her mom, but not real quick. All right.
No, you're not. Your mom's probably gonna be like, no.
So friends, we are finishing up this unit between today and tomorrow, and we got a quiz on Monday. Cool. And then
This is on elimination and substitution.
and graphing, yes. So
Wait, hold up.
holding up. Remember.
We ever done graphing?
Okay.
Are we doing it today?
No, it was first. It was right before Thanksgiving.
Just stop.
That was so confusing.
All right, and then after this quiz, we are starting systems of linear inequalities, which just means we have less than and greater than signs with the same thing we're working with, and then we'll shade regions. And then looks like so the quiz will be Monday, and then we have Tuesday through Friday is kind of normal, and then the 10th of December, which is a Monday, we will be finishing up the unit. Then on the 11th, I'll give you the take-home test. And then we will do the in-class test on the 12th. I'll probably actually give you the take-home test on the 10th as well. And then it looks like we have, wow, we're coming down quick. We have 2 days that we will review for finals, which would be the 12th, it's December 13th and December 14th, which is a Thursday and a Friday. And then we have the Monday, which is the December 17th. We have kind of a written portion of the final. And then between 12:18, 12:19, and 12:20, one of those days we have fifth period final, in which your final will be, the rest of your final will be on Schoology. Okay? Good. So we've been talking about just one, I haven't used this verbiage yet with y'all, but I was hoping you would catch on to it the other day when we talked about, the final 3 weeks. You got to finish the semester strong, okay? If you don't, that could impact your grade in a way that you don't want it to be impacted. Would you agree with that?
Yes.
What's my password? Anybody? Oliver? That's right. Oliver is the best is my password. You got it. Is he really? You hack? It's okay if you do. You try? What do you say?
Yeah, I can hack the camp.
My friend almost hacked a military base, but they caught him.
Okay, this isn't war games, they're gypsy.
I can hack a military
Like, I'm
base.
not joking. It was bad.
I think he's fibbing.
That kind of stuff and get like free games. Yeah, bro. Yeah, bro.
Wait,
my
download
friend was
the
also
Google Math
part of the Scorpion team.
You must be a
That
cheater.
Yeah, my guy was in the GI
yeah, my guy.
but he got caught.
He's in the Navy SEALs and he almost hacked into Russia's base, but
Oh, here we go.
thank God they caught him. Thank God.
I know
America got
this
him.
Space Marine. He's on Jupiter right now.
Sophia
Oh.
very bad because he just disrespected
Yeah,
the
that's
country.
my culture. Don't.
What's wrong?
You culture.
Yeah.
I just bought this like 30 minutes ago, so check it out.
Nice facts.
Okay, let's get the homework out from last time. What page were we on? What page? 141.
Do you want me to turn off the lights?
Yes, please. And
I like it when it's 100% dark.
we could be pretty dark. We probably have to take those lights out and then put tape over those and those, and because we don't have any windows in here. We're like in the tornado-proof room.
Yeah, think about it, bro.
We're right next to him.
Alright, so if a tornado ever happens, just lock that door so no one else can get it.
Yeah, buddy. And sit there and wave. You're right.
When the zombie apocalypse is happening outside, we're bunkering down in West Pits.
And then we'll go up through the ceiling and move through the ceilings.
Who weighs the
Okay,
less?
zombie
Who weighs
apocalypse.
less in here?
How do you know that we
Oh,
Alright.
bro.
Okay, I had asked you to do, what was it? The odds? Is that what it was?
Thank God there's
Or the evens?
pictures.
All right, let's take a look. So let's just kind of march through these, see how we do. I know I didn't actually do all of them, but kind of use this as notes as well. So I'm actually going to go through and do most of the problems. But I want you to feel comfortable with it and follow along kind of as we're doing, like use this as notes, okay? Okay. So if we're using the elimination method, on these, what do you feel I could do right now with these problems?
Cross out. Why?
So they're ready for me to add them together? Does everyone agree? These two problems are ready to cross out? Everyone agree with that? Anyone stuck on why we can do that? All right, so if I just take these equations as they are right now, I can add them up and the y's cancel out, yes?
Yes.
All right, 3x, 2x added together, give me? 5x, yay. And then equals 20, is that okay? So I get x is equal to 4. So there's one of my answers right there, 4 comma something. Okay, what should I do to figure out the y? Plug it in where? Into the x on which equation?
3x.
Either of them. So it doesn't matter. It'll be the exact same answer on both. Okay, so I'm going to either pick this x or this x. It doesn't really matter. So I'm going to get 2 times 4 plus y equals 8. Yeah, cool. So we find that y is equal to 0. So if I had graphed these, where would these cross? 4 comma 0 they would cross.
Wait, I have a question.
Yes.
How do you know if you need to, how do you know when you can just start adding?
So this one worked really nice because we had already had opposite y values, and there was a positive y and a negative y. Sometimes we would have to start multiplying. So when I showed you yesterday in the notes, you had to multiply them. So we might get to that a little bit today. So again, I'm going to go through all the problems, though you were not expected to do them all. Okay. And then what was that? 4x minus y is equal to negative 9. Is that right? All right. I'm going to take this out here. Ask if I want to go to tablet mode, and I'll say yep. All right. So are these two equations set up to add up and something cancels out?
Yeah.
Everyone feel comfy with that?
Yes.
Sweet. So if I add these together, the x's are gone, so I get 2y is equal to 2. So what's y have to equal? 1. So here's my answer. I have an x and a y value. Which value do I know right now? Y. So I'm going to take my y value and plug it into either of the y's. Doesn't matter which one you pick. It'll be the same. Is that okay so far? Justify my math. So that just gives me 3, right? So if I subtract 3 from both sides, I get to 8. And x is equal to? Negative 2. So if I had graphed these, where would they have crossed? Negative 2 and 1. Good. And then let's take a look at number 3. So x minus 4y is equal to 24. And 5x minus 6y is equal to 8. All right, can I add these together right now? Why not? What doesn't fall out? Yeah, so if I add these together right now, I wind up with 6x minus 10y equals 32. So if I add them together as they sit now, nothing's going to drop out. So then we have to decide, okay, what do I want to get rid of? Do I want to get rid of x or do I want to get rid of y? And there's really not a right or wrong answer.
Get rid of y.
Get rid of y?
No.
No?
Yeah, it'd be easier. Well, you could do either way. So,
Yeah,
get rid of the
because
y.
Get rid of y.
So I will tell you this. If I get rid of y, and I like that, I would have to multiply this whole top by, say, positive 2 or positive 3, and this whole bottom by negative 2. Okay? Is that what you guys want to do?
Let's do it.
Would there have been a shorter one to do if we did the
No.
other way?
Let's do it this way.
There would be. What would I multiply the top equation by to get rid of
That's
x?
my order, just do y.
Yeah. Or I could multiply just this by -5. Take a look up there. Eyes up there. So do you want to multiply? I mean, you're going to get the same answer either way. But if I multiply this whole thing by -5, I only have to deal with one of the equations where things are changing. -24, 5 times -24, 20 is -120. And then I can just move this one straight down here. So again, you would not have been wrong if you had used this way. It's just you would have had to have done a little bit more math. So if I add these together, those are gone. I get 14y. Hey, help me out. What is -120 subtract 8? What is -120 subtract 8?
-112.
Oh, you're awesome.
You're not wrong.
And then if I divide both sides by 14, how many times does 14 go into -112?
Wait,
8?
-28.
I'll go with the -8, but
Oh
close.
wait, sorry. It's -8.
How did you get 120y? I mean, 20y?
This one right here,
Yeah, wait. So you multiply
I multiplied
them all
here,
by
here, and here. I did the -5. Because you only had to do one.
Wait, why do you have to do -5?
Because you want your x values to be opposite value.
Okay, so if it's -5, then it'll be a 5.
Yep. All right, so I have a y value of -8. Agree? So if I take my y value and plug it in here or here, I'm going to get the same answer. I might choose to do this one. So I'm going to get x minus 4 times -8 equals 24. So x plus 32 is equal to 24. What's x got to be equal to? Careful. It's negative. I'm going to subtract 32 from both sides, right? So it's going to be a negative answer, and it's going to be negative what? What's the negative? -8. Hey, cool. We got. That's okay. What do you think? We good? All right. Take a look at 4 through 9. Are there any of those you'd like to see worked out? Not feeling comfortable with it. Take an honest look at them. Yeah. 7. Is there anything else from 4 through 9 you'd like to take a look at? Yeah. 8. Anything else 4 through 9 you'd like to take a look at? Me.
1 through 9, is that what you said?
Yeah.
Never mind.
Never mind. We're good. All right. So let's take a look at number 7 first. So I get 2x minus 3y equals 17. And I get 4x minus 6y equals 25. Okay. My friends, if I add these two equations together, I get 6x minus 9y plus 42. That's not going to work.
The y.
Equals 42.
So you're gonna do 4.
You're going to do -2.
What are you trying to get rid of?
X.
X? With
Yes.
-2 on which one?
You're gonna multiply.
Multiply the old top one by all by -2. Let's bring this down.
-4.
-4x plus 6y equals -34.
Oh, look at how smart you are.
I was thinking she's
A gold digger.
All right, if I add these together, those cancel, right? Uh-oh. Those
Guess what?
cancel.
It's no solution.
I get 0 is equal to -9, and we didn't find one of the greatest secrets on earth. We realized that it was no solution. Hey, what kind of lines, I know they're straight, but what kind of straight lines would this have graphed to be if there's no solution?
Parallel.
Parallel. Does that make sense? Cool, good job. Let's see, number 8. Okay, take a look at these, my friends. What do you want to get rid of, X or Y?
Let's get rid of
X.
X, so I'll multiply this whole top equation by 3. So this is going to be 12x minus 9y equals 36. Yay. And then bring this one down. Negative 12x plus 9y is equal to negative 36. So if I add these together, I get 0 equals 0. Infinite solutions. So if I had graphed these two linear solutions, okay. If I had solutions, okay. If I had graphed these two lines, what would have happened if I had graphed these two lines? Yeah, they're right on top of each other. It's the same line. Cool. All right. Questions on 10 or 11? Questions on 10 or 11, because 10 or 11 are graphing in which Sophia doesn't. Both of them? I'll hit it. So these are both set up to graph. And I'll try and make my best graph that I can.
It'd be 1x.
Uh-oh, come on, baby.
X plus 7.
Kind of close. All right, what's my y-intercept of this line? 2. And a dot. So I'm going to go do what to get the next dot? Up 1 and over 3. Agree? All right, then let's do this one in a purple. What's the y-intercept of this one?
Wait, you go up 1 over 3?
Yep, because that would have slope of 1/3. So y-intercept of this one's 5, so I'm going to 3, 4, 5. So from there, I'm going to actually go up 2 and over 3. Oh. Okay, now question. Let's think logically about this. What's the slope of the top one? 1/3. What's the slope of the bottom one? So are they are not parallel, right? So they're going to cross somewhere down here. I can't really see where they're going to cross, can I? Okay, maybe I didn't do my graph well enough, but does everyone agree that these are not parallel? So there is some XY solution to this problem. It's just, I don't think that this would have intersected on our grid. Is that okay? Because it doesn't intersect on our grid doesn't mean there's no solution. And again, this is one of the things that we say, hey, it's best if we did these problems probably as substitution. So I'm going to set the two equal to each other. Is that okay? Let's see, subtract 1/3. So if I get 1/3 x over here, subtract 5, so I get negative 3 over here. Multiply both sides by 3, so x equals negative 9. Oh, okay. So that's negative 9 is like way over here. And then if I wanted to find what my y value is, plug that in maybe there. So 2 times negative 9 is negative 18. Negative 18 over 3 is negative 6. 6 added to 5, negative 6 added to 5 is negative 1. Oh. I guess we probably could have seen it on the grid that was given to you. It's just I didn't have a fancy enough grid. I'm sorry.
I low-key got that answer.
Oh my god. Wow.
All right. Do you all see how though I went from graphing to substitution, and it gave me the answer, which is great. And again, you probably had really nice, neat graphs, unlike your teacher. All right. Number 11. We have 3y plus 4x equals 3. And then x plus 3y equals negative 6. Ooh. Ew. Oh, boy.
This is an ugly problem.
Yeah, baby. All right. If I did the cover method on, whoops, I forget, I got goofed up. 3y, that's a 4x. That's a 4x right there. All right. If I did the cover method, I'd get 3y equals 3, so y equals 1. If I did the cover method here, I get x equals 3/4. Ooh. So like 3/4. That's not pretty. Okay. If I did the cover method on this one, I'm going to get x equals -6. If I did the cover method on this, I'm going to get y equals -2. They do indeed look like they cross.
Yes, sir.
Just, I mean, here's definitely where they're crossing, but I can't see it on my grid. Did anyone get a nice graph? What'd you get? 3, -3. If we weren't sure about our solution, what should we do to both the equations? Yeah, plug them in. So let's plug into this top one. So I'm going to get -9 plus 12. Is that equal to 3? Yep. And then on the bottom one, I'm going to get 3 minus 9 equals -6. And that's also works. Sweet. So that is absolutely correct. Good job, Joy. Okay. Y'all probably nailed the word problem and don't need anyone to go over, do you?
Right. I nailed it. Actually, I did.
Did you? Good deal. All right, let's take a look. So number 12, I'm actually going to skip it because I won't test you on this one. Okay. What'd you get though for an answer?
I got n equals 15 and d equals 14.
Cool. Okay. All right. Now number 13. The reason I'm going to show you number 13, you're going to have a problem just like this on the quiz. That is this.
Bet.
Is that okay?
Time I'll take notes.
So if it's extra credit, it's like, man, I'm going to really work hard right now. I don't understand the rest of it, but I'm going to nail the extra credit. Okay. Good. Okay, that's the extra credit problem. So this is where this kind of stuff's get a little goofy. This is actually 3 lines that will intersect each other in 3 space. So you have your x, your y, and your z axis. Okay? So let's do this. Let's take my first 2 equations, and what would happen if I added my first 2 equations together as they sit right now? It gets rid of a y, right? So I'd get 2x plus 2z equals 56. How does that seem? Is that all right? So I'm going to take that equation.
Why don't you include the
I'm going to right now. And because look at the letters that I have on this one. I have x and z, right? So I have 3x minus z equals 4. Okay? Let's do elimination on these right now. If I add them together, do any of the letters fall out? Is there something simple I can do to one of the equations to make, say, the z's go away? Yeah, I could multiply this whole thing by 2. So I'm going to rewrite this one here. This one's not changing. And then this bottom one, I get 6x minus 2z equals 8. If I add those together now, look what I get. I get 8x. The z's are gone. Excuse me. Equals 64. So what does x have to equal? 8. So I have one answer of 8. So now I want to find my y or my z value. Okay? So a good thing to do is pick one of the equations that has an x and one other letter. So pick either this equation here or this equation here. Doesn't matter which one you pick. Okay? I might pick the top one. I'm going to plug in for my x value. So I'm going to get 24 minus z equals 4. So negative z equals negative 20, I believe. So what's z equal to? 20. So now, did I do it right? Question?
How did you get 24?
I don't know. Where? Did I really make that line over here? Where did I? 8. Oh, 3 times 8 is 24. Cool.
I don't know how you.
We good? All right, so we now know an x and a z value. What value am I looking for last? I'm looking for my y value. So I need to figure out either of those equations to plug in 8 and 20 for x and z. So maybe I'll pick this one. That's a 41. So I get 28 plus y equals 41. Subtract 28 from 41, I believe it's 13. So if I had drawn this in three-dimensional space, these lines would have intersected at 8, 13, 20. Can you see how these are starting to get a lot more complex? May I take you on a adventure a little bit further than this? Make your minds
Wait, does that say negative 41?
just positive 41.
Did you see that video where the guy paid $20?
What happened?
Did you see the video where the guy paid $20 to massage this girl's tays?
What?
No.
And then he sniffed her sock. And then she was like, okay, I'm good.
Why?
One girl that named her son ABCD.
Why is this relevant?
Actually, she was on a flight.
All right.
Attended his card.
So
She walked up to 20.
ABCD.
That moment when you pay, you give them
ABCD. What's up, man?
What is this?
It's ABCD.
Are you being serious?
You know whose last name is ABCD?
Your computer has what?
Jacob. Baldessar, right?
Just let.
Baldessar.
All right. Have you ever done this before?
Made 2 boxes.
That's it, right?
Made a 2D. Yeah, I mean 3D box. No, you haven't. Yeah, that's so easy. You just like he did.
Yeah.
Okay. Have you all done that before?
Yes.
You're bored, right? So is that a three-dimensional box? It's meant to look like a three-dimensional box, but is it truly a
This is
three-dimensional
so
box?
trippy.
No, because I drew it on two-dimensional space. Is that right?
Yes.
Is it flipping back and forth at you?
You gotta move.
It's crazy.
Okay. So we've all seen this before?
Yes.
All right. I'm gonna put. All right. So the problem we just did with the three-dimensional space, the XYZ, is what the grid would pretty much look like. Okay? You ready for it to go? You ready? You think you're tripping now? Watch this. All right, I'm going to copy my whole thing.
Jesus Christ. You don't have to repeat it like 500 times.
What was that noise?
Yeah,
You know what? I want to know what song you're beating now.
For $20.
I'll pay you $30.
For what?
Wait, are you gonna put the other one?
Okay. So now I have two three-dimensional boxes, both being represented in three spaces. Still with me?
Yeah. 2 2D 3D. 2 2D 3D. 2 2D 3D. 2 2D 3D boxes. In the 2D dimension. That is so hard. Let's go ahead and one do on this one. 2 2D 3D dimensional boxes in the 2 dimensional space.
I wish I would change the color. I'll just do this.
Gucci flip flops. Make her kick rocks. Busted.
Sweat. I see a diamond.
Shut up.
Whoa.
Wait, what? Gucci flip flops. Make her kick rocks. Busted.
Dude, this is so.
It's coming.
So tripped out right now.
This is what we do in class.
This last one.
Okay.
Oh, it looks like there's like 2 lines.
Okay. So what I just did is I took two three-dimensional boxes represented in two space. I duplicated it and I connected all the appropriate vertices. By definition, this is what a fourth-dimensional object would look like in two-dimensional space, represented as a three-dimensional object.
So how many dimensions are there?
Infinite.
Okay, so this is just 4 of the infinite dimensions.
Yeah, we're not seeing the fourth dimension.
But we're in the first dimension. Right?
No, we're in the third dimension.
We're in the third dimension?
Yes, length, width, height.
So is like the 4th dimension like a plane above or something?
So here's the weird thing. Your minds can't think. You can't really fathom what a higher dimensional object would be because we don't exist in it. We can see lower dimensions than us. We can easily see the second dimension because we can look at a piece of paper and write all over it. We can see the first dimension because we could just take a line and say, look, there's a seam there or a line there. So the first dimension, you see where this wall and the ceiling intersect and it makes that line? That's a one-dimensional line. So you can see it, right? If you want to see a zero-dimensional object, that's called a point. So look in the corner where the 2 walls and the ceiling meet, and that's a point. So you can see the wall, you can see where the ceiling and the wall come together, or the 2 walls come together, form a line, where the 3 planes come together, the wall, the ceiling, and the other wall form a point. So we can see all these lower dimensions without any problem. We just can't see at a higher dimension, but it exists. So now let me really poof you. Let's go with some good type of logical thinking. Let's say something lived in the 2 dimensions. So things that we could say that are probably small enough to live in the 2 dimensions, they really do live in the 3 dimension, but they're really small, would be like a virus.
So what's a 1 dimension?
That point right there where the walls come together, there's a point. That's 1D. So then we would just see point. That's it. We would be. So a virus is a very small object. And you might not know this analogy, but a virus is so small, if you were to take your traditional bacteria and expand what it looks like, a bacteria would be like the size of the Stutler Bowl. You still with me? You know our big stadium over there? Yeah. The virus would be the football sitting somewhere in there. That's the size difference between a virus and a bacteria. Okay? You're talking about thousands of times smaller. So in theory, a virus could be living in the 2nd dimension. Do viruses mess with us? Oh yeah. You get that cold, you get that flu, you got a virus. Okay? So, think of that. Things that are at such a small level, dimension-wise, can affect us. We can affect the virus because we can destroy the virus because we can incinerate it, meaning you burn it, and it's gone. Okay? Now, if we are able to influence something in the 2nd dimension, and something is able to influence us in the 2nd dimension to the 3rd dimension, What is above us in the 4th or 5th or 6th or 7th or 8th or 1,000,000th dimension? Because they can definitely, if there's something that exists, that existence could be seeing us right now.
That's deep.
So I just showed you mathematically that these dimensions exist. You can't disprove that they don't exist because mathematically I can prove it's working. So do you think you could take 2 shoe boxes and take a piece of string and connect each of the corners to it? So then you just created a 4th dimensional object in 3 space. But you don't know what the 4th dimensional object necessarily looks like.
A one-dimension,
Is a point.
like, world wouldn't exist.
So you say. Now, let's go one little smidge further for you. Okay? So,
It would be infinitely small. So
absolutely.
contracting, so it'd be
Let's go even more wackadoodle. Have you ever looked at the art on the wall? It's like a poster and it's just like the same fractal type of thing over and over, and if you get real close to it and you start coming away from it, all of a sudden it looks like a 3D image coming out at you. You ever seen this? That is actually something in the 2.5 dimension.
What?
It's an interdimensional part.
What about the 2.71563?
It might be that one too.
It's your depth perception.
It's depth perception, but they're using the 2nd dimension, using an algorithm to make it bend to go to the between the 2nd and the 3rd dimension.
Like, that's so
So
creepy.
you're talking about a partial dimension.
How would you have, like, it'd be like the opposite of plane.
No, it's not all the way there.
So then that would just be half the shape.
Here, Oliver, I'll give you this. So a lot of people will say time is a dimension. By definition, a definition of a dimension is something that you can go backwards and forward in, but I can only go forward in time. So time's theoretically only a half dimension.
Oh,
No.
I mean, can't you go backwards if you create like some sort of time machine or something?
You have to go faster than the speed of light, and by using the kinetic equations in physics, in order for you to accelerate the smallest particle to go faster than the speed of light, you have to use the summation of all of the energy in the entire universe.
What the frick? Dude, my head is about to explode.
What? Wait.
Like one side of this is really
Do we really need to know this?
That's like a Stephen Hawking.
I want to be a real estate agent.
Huh?
I just want to be a real estate agent.
I feel like she'd be a good real estate agent.
Yeah, I got the look.
All right.
It was a joke.
This worksheet that came to you was basically, could have been notes, but I think they're good problems to work through. So I will be collecting this tomorrow.
Okay.
Yeah. That cool?
Yes.
Hang on to last night's homework, and if you're here, I'll put points in for you. So put a 4 at the top. Sound cool? Hey, what page did we do last night? 141. Thank you. Oh, man.